Okay, good morning everyone, welcome back. Couple things that we want to do today. The first thing, I'm just going to type this in for my own record here. Geogebra tutorial. Now, I realize a couple things. First thing is, some of you might still be having issues with like creating a OneDrive folder and sharing it with me and stuff like that. And if you are having issues, flag me down after class. I plan to go in and double check and see all of your work sometime this afternoon. So if I search for somebody's folder and I don't find it, you might be getting an email from me saying, hey, something isn't right with your shared folder. But we can figure that out. The second thing is, I don't know what is going on with these two links, but when I click on the link, it takes me to Function and Graphs 1 and Function and Graphs 2. I think it has something to do with the browser history or something like that, because I think when some of you clicked on there, it was taking you to a different tutorial. One of you was even working on the geometry tutorial, and I'm like, wait a second, that's not even the right tutorial. So I don't know, did anybody have issues with that? Like you were working on a tutorial and then you're like, this isn't even the right tutorial? I don't know what the heck's going on.
But I know when I was working on the second one, I was in the first link and I finished it, I took my snapshot, and then it took me to like the next one.
Right.
So I didn't click on the link, but while I was doing it, it got to like the end point where it was like, it didn't give you step-by-step instructions, it just said, hey, build this triangle kind of thing.
Yeah, because you were in the geometry one.
Oh, okay, yeah, I was doing it and I built it like 4 different times and it wouldn't work, so I wrote just a little note.
Yeah.
And I screenshot it.
Yeah, that's okay. I'm not going to worry about it. Okay. What I really wanted for you to get out of this assignment was just to go through and use the different tools and see what's underneath the different menus. It was just an exploratory thing, okay? If you have a green dot missing and whatever, don't worry about it. I'm just going to give you credit for completing the exploration, okay? So don't stress about your grade. Now, was there any specific function or step or feature or something that you just could not figure out? Certain step that we want to talk about, couldn't find the button, couldn't find how to do it?
I guess I have one thing.
Yep.
If you didn't finish it, you had to I think you had to finish it the whole period, right? You couldn't really go back to it.
If you go back, I think it made you start over from the beginning. Yeah, and a couple of us talked about that at the end of class after everybody else left. So did anybody fall victim to that and you had to start over and do it all over again?
Yeah, I was begging the lady to get out of my store so I could finish it. From the end, and she was taking a really long time.
I apologize if this assignment became stressful for you. It was supposed to be a very easy assignment. So, anyways, if you worked really darn hard on it, you probably had a good learning experience. So let's go with that. Any other specific functions of GeoGebra that you want to talk about or you want to ask about? Going once? Going twice? Okay. Like I said, I'm going to search your shared folders and just see what you did, and then you might get an email from me if I can't find your shared folder or something like that. But we'll call that good. So here's what I want to do. We are going to work on the Algebra Chapter 2.2 and 2.3 over the next 2 days. Mostly 2.3, but I want to do a little bit from 2.2 today. Just a reminder, remember there's that Alg 2.1, the quiz, the My Open Math quiz, and there's an Alg 2.2 and there's an Alg 2.3 and so forth. You should now be working on those, like 2.1 you should be able to do. 2.2 is what we're going to kind of work on today, so you should be able to start that after today's class and just work on those incrementally until they're all due when? The day we take the test, right? And we're going to go all the way down to 2.7 before we take that algebra Chapter 2 test. So there'll be 7 of those quizzes that you'll want to have finished by the time we get there. But let's look at section 2.2, which is linear and rational equations. Now I said the other day that we're not going to spend the whole darn time doing equation solving, right? That's not what math is. Math is not just equation solving. That being said, we are going to do a little bit of this and a little bit of practice A little bit of refresher on your algebra skills, okay? Equation solving. So I want you to grab a piece of scratch paper, and I want you to tackle these 4. You're not going to hand this in. This is just for practice. Just with paper and pencil, a little refresher on your algebra ability. I want you to solve for x on all 4 of these. And then we're going to go over some solutions together. So if you're not 100% sure how to do some of these, that's okay. That's why we're here. My hunch is the top 2, you're going to be able to handle a little bit easier than the bottom 2. I'm going to give you a few minutes to work. Okay, I'm going to pause you for a second. I want to talk about this first one really quick. My hunch is we had little to no problems with this one, and now something's not working on my, oh, hold on, enable editing. Here we go. This is about as simple as it gets. Depending on your algebra teacher and how you learn this, I look at this and I say subtract 1 from both sides, so 2x must be equal to negative 10, and then I divide both sides by 2 and I say x is equal to negative 5. How do we do there? That's 8th grade stuff. I assumed you can handle that. Little bit tougher with this second one. I would probably say distributive property, negative 6x plus 2 plus x equals 14 minus x. And now I just got to gather all my like terms. So over here, if I gather those two, that's negative 5x plus 2. And I can move this x over to the other side. So if I add x to both sides, negative 4x, and subtract 2 from both sides. So negative 4x equals 12. Divide both sides by negative 4. X equals negative 3. How'd I do? Good? Confident? Not too bad? Okay. How many of you were able to finish this one yet? Anybody got it yet? Nobody? You got it back there, Harmony? What'd you get?
X equals 6/20.
6/20? I got something different. Anybody else? What do we know for sure x does not equal before we get started here? X does not equal, somebody said it. Yeah. Do you guys see why x cannot be 0? If x was 0, it'd be 2 divided by 3 times 0, which is 0, and it'd be 2 divided by 0. What is 2 divided by 0? Undefined. We know for sure x cannot be 0, right? Harmony, when you decided to solve that, what was your first step? What did you try to do?
I moved the 1/6 x over.
Okay, so you went 2 over 3x plus 1 over 6x, whoops, equals 1/4. Is that legal? Can she do that? I think so. What'd you try after that?
And then I tried to add the 2/3 and 1/6.
So can we add these two fractions together? Only if what? Yeah, they'd have to have a common denominator first, right? And I think we could get there. But I'm gonna scratch that plan for a second. Does anybody have a different plan? Wouldn't it be nice to get rid of those denominators? I mean, the first two were easier than the second two based on that the first two didn't involve any fractions and the second two do involve fractions, right? And if you had to choose between solving an equation that involves fractions and solving an equation that doesn't have fractions, I would choose the one that doesn't have fractions. It's just it makes life simpler, right? This is what we call a rational equation, ratio. They're fractions. Our x is in the denominator, okay? That's what makes them a little more complicated. One of the ways to tackle this is to find what we call our lowest common multiple of our denominators. Our lowest common multiple. So we got a 3x and a 4 and a 6x. So what value can all three of those divide into? Can you guys do an LCM in your head? 24. Does 3, 4, and 6 all go into 24? Yes. That is a common multiple, but what's the lowest one? 12. Yeah, so if I look at just the 3, the 4, and the 6, they all go into 12. But some of them have x's, right? So what is my total lowest common multiple here? 12x. Yeah, my lowest common multiple is 12x. 12x is my lowest common multiple. So if you can find that lowest common multiple and then take both sides of the equation times that lowest common multiple, you're going to find that everything's going to cancel out and clear out and give you a very easy equation after you do that, right? So what I'm going to do is I'm going to take the left-hand side of the equation, and I'm going to take it times 12x. And as long as I do the same thing to the right-hand side of the equation, you know, whatever I do to the left, I do to the right. If I take the left side of the equation and the right side of the equation times 12x, that's perfectly legal, right? Watch what's going to happen now as you multiply these. Go to the left-hand side. The x and the x just create a 1, right? X over x is 1. One of my college math teachers used to say the x's go to Texas. So if you like that, the x's are gone, right? What's 12 over 3? 4. What's 4 times 2? 8. That whole thing simplifies down to 8. See how clean that is now? Did I lose anybody there? 12 times 2 would be 24. 24 divided by 3 is 8, right? Okay, now this guy. I got to distribute. So I got to take the 12x times him, and I got to take the 12x times him. 12x times 1 is just 12x, and 12x divided by 4 is 3x. 12x divided by 4 is 3x, right? So I did the first one. Now I got to do the second one. 12x over 6x is, the x's go to Texas. 12 over 6 is 2. And now I have a much, much simpler equation, right? So if I move the 2 to the other side, I would say 3x is equal to 10. So x must equal 10 thirds. Now I think you said 6 over 20, right? You should have said 20 over 6, because 20 over 6 would have been the same thing. So somehow your numerator and denominator got mixed. So I don't know if you found your error in there or not, but so I got 10 thirds, or 3 1/3, if you want to think of it that way. Kind of complicated, right? Let's look at this one. We have a denominator problem again, don't we? Can you guys identify the lowest common multiple? Doesn't have to necessarily be the lowest common multiple. Like 24 would have worked, by the way. We just would have had more canceling to do later on, right? As long as we find a common multiple, we're good. What's our common multiple going to be here? Nope. We got 2x plus 1 and we got 3x plus 1. So think of them as individual guys, right? 2x plus 1 is a guy. 3x plus 1 is a guy. This goes into what and this goes into what? Well, the common multiple is just going to be multiplying both of them together, right? So we have to take both of them times this whole darn thing. But one of them's going to cancel, right? Go ahead and see if you can do this. I'll give you a minute to work on it. See if you can handle it. We're going to take both the left and the right times 2x plus 1, 3x plus 1. Times that thing. So if you're showing your work, it would look something like this, where we are multiplying both sides times 2x plus 1, 3x plus 1. But you should see some cancellation coming here. And once things cancel, our denominators go away and everything is nice and easy. Somebody flag me down when you have a final answer on this one. I'd like to see what you got. Anybody got an answer? Don't be shy. Need my cheat sheet for names again. Charisma and Isaac. Ashley and Tabitha. Martin and Riley. Did you guys get anything yet? Hannah. Maddie. Grace. Colby. Denise.
You going farther than that?
Where's your final answer? Yeah, so
Then I have to.
you would have got,
That's what I did.
so you would have got 3x minus 1 times the minus 3. So that's negative 9x minus 3. But it's not over.
Okay,
It's
so
equal.
there's more.
There's an equal sign. You took this and you put it over this. But it's actually this is equal to this.
Okay.
So that thing you have down in the denominator, it should be up here.
On the right.
Equal. Yeah. Yep. You changed your equal sign into a fraction somehow. Anybody got something? What'd you get? All right. Our first customer.
Oh boy.
No. Good try, though. What'd you get? Fantastic. Yes. Excellent. Yes. Very nice. Except that 13 is supposed to be a 17. So I think you missed a negative sign in there somewhere. That 13 is a 17. Okay, let's talk about this in the interest of time here. If you multiplied both sides times this common denominator, notice what happens. This guy, 2x plus 1, the factor on top, cancels with the 2x plus 1 on the bottom. Because it just equals 1. That's what canceling means, right? When a numerator and a denominator are exactly the same, it just equals 1. And anything we take times 1, we can just ignore it. That's why we cancel it. That's why we cross it out. Same thing here. 3x plus 1 over 3x plus 1 is just 1. So taking it times 1 is like ignoring it. So now I got to distribute. Negative 3 times this guy. So I'd get negative 9x minus 3 on my left-hand side. And over here I have to distribute, right? 8x plus 4. And when I do that, plus 4, when I do that, now I have another simple equation that I should be able to handle. Like the hard work is done now, right? Now I just got to gather everything. So if I move the x's to the left, it'd be negative 17x. And if I move the constants to the right, equals 7. And if I divide both sides by negative 17, I get negative 7 over 17 as my answer, right? Some of you may have noticed that multiplying this one by the common multiple actually turned out to be the same thing as just cross multiplying. Maybe you guys learned how to cross multiply when two fractions are equal to each other. Because if I cross multiply, I get negative 3 times 3x plus 1. Well, isn't that what I ended up with right here? Negative 3 times 3x plus 1. And if I cross multiply this guy, I get 4 times 2x plus 1. Well, isn't that what I got right here after everything canceled? 4 times 2x plus 1. So I would have got the same answer if I would have cross multiplied. Before we even started, we should have been able to tell ourselves that x cannot equal what? You guys do that in your head? Is 0 going to cause us a problem? I don't think so. Because if I go to my denominators, 2 times 0 is 0, and 0 plus 1 is 1. I can have 1 in a denominator. I just got to make sure I never have 0 in a denominator, right? So what value of x would make this 0? Can you guys do that in your head? If 2x plus 1 was equal to 0, wouldn't x be negative half? Negative half would give us a problem, right? Because 2 times negative half is negative 1, and negative 1 plus 1 is 0. What guy would give us a problem in this denominator? Negative 1/3, right? Wouldn't that cause him to be 0? So we know that x cannot equal these. So if we went through that whole darn solving process and we found out that x was one of those two things, then we would have found out that that actually isn't a solution. And when we get later on, I'll show you where we can sometimes get extraneous solutions through our problem solving. We're going to do that in section 6, I think. So as far as practicing these, here's my message to you. Utilize your textbook. There are examples in the textbook. There's lots of them. There's homework examples. There's video links at the end of each section of your textbook. And then that My Open Math where I give you those quizzes, what do you think your 2.2 quiz is going to look like? Something like the ones that we just practiced, right? And you get to practice them over and over again until you get them right. And then there's video links in there too. So let me just show you really quick what I'm talking about. If you go to your textbook, math, I'm just going to open it from my computer here. Remember, we're on that first college algebra textbook. We're using that first textbook for this first chapter, and then we're going to go to textbook number 2. Do you guys remember that from the first day of class? So we are currently on 2.2. Look at all these examples that you can do here. Here's a couple easy ones like 2.9 and 2.10. That's kind of what we just practiced. But these tougher ones with the rational ones, with the fractions, here's some more to practice. 2.11, 2.12, 2.13. You can practice these from your textbook. And at the end of your textbook, at the end of every section, there's some video links. Solving rational equations. That'll take you to a YouTube video. Okay? Also, you'll remember that when you go to your tutorials, quizzes, and tests in Blackboard, you can go to the Algebra 2 chapter. We're on 2.2 linear equations. Solving multi-step problems, solving rational equations. Again, these are videos that you can watch if you're kind of stumped on this, okay? And then when you go to your assignment, your 2.2 quiz, take a look at some of the practice problems that you get to work on, just like the ones we were just working on here. What I'm telling you is you have ample opportunity to practice all of this and watch videos and go back and watch class. You practice as much as you feel like you need to, all right? And then, of course, finish this quiz because you actually get a grade on the quiz, right? Comments, questions? Going once, going twice? Okay. I'm going to jump to a beginning intro of section 2.3 here. Whoops. Give me a second. And I'm just going to have you follow along here on the screen. This is what we call linear models and applications. Okay? So word problems in another sense, or story problems, or application problems is what we're going to kind of work on. Let me give you a refresher of day number 2 in class. Remember our friend Conrad who said these are the 4 steps of solving or working mathematics? Okay? I want to work not so much on number 3. We know that that's important. But I want to work on number 1, 2, and 4. That's what we're going to focus on here. Okay? So, number 2, apply a mathematical model or an equation or a formula to the situation. That involves us being able to do standard number 2, to be able to reason both abstractly and quantitatively. When we reason quantitatively, that's arithmetic. We add, subtract, multiply, and divide numbers. Okay? When we reason abstractly, that's algebra. That's when we use x or n or some variable. I don't know what x is, so I'm going to assign a variable. I'm going to let x equal something, and I'm going to do math on x instead of math on numbers. Okay? You guys might even go all the way back to elementary school when they gave you 3 plus box equals 5. And you had to fill in the box, right? That's very little kid stuff, right? Well, algebra is also kind of little kid stuff in the sense that eventually you got to 7th or 8th grade, and instead of doing a box, they did what? They didn't do boxes anymore. Letters, x's, variables. They said 3 plus x equals 5. And half of the math students went into a total panic because now there's letters in math. And I've never done letters in math. Okay? Well, if you think box is easy, just think of the X as a box. All you're doing is trying to figure out, well, what is this X thing? It represents something I can solve for it, right? That's what algebra is in a nutshell. So let's just work a little bit on setting up these scenarios with variables. Here's a little grid, okay? On your scratch paper, see if you can fill in the translation into a math operation. So the first one, we'll do the first one together. You have some number, okay? And then you have another number, and one of the numbers exceeds the other number by a. So one of them is a larger than the other one. Okay, so we have two numbers. One of them is a larger than the other one. Abstractly, what could we do to represent those two numbers? I have two numbers. One of them is a larger than the other one. Anybody want to rattle off what we could do? Create a variable. Let's just give our first number some name. What should we call the first number? What's our most popular letter that we use in algebra?
P.
P?
P.
Usually it's X. But we could use P if you wanted to, right? Sometimes we use N, right? It doesn't matter what letter we use. But for the sake of following along with my PowerPoint, we're going to use X. Okay? Let's say I call the very first number X. So one of my numbers is taken care of. We're just going to call him X. What would my other number be? Not A. Close, though. What's the relationship between my two numbers? One of them's bigger than the other, right? So I already have X. Not X to the A power, because it's not, it says exceeding. If we exceed it by A, we would add A to it. It's A more than it. Or we could, so if I call X the small number, the bigger number would be X plus A, correct? What happens if X was the big number? What would the other number be? X minus A? Depends on which one's the big one and which one's the small one. So one way we could do this is to say one of my numbers is X and the other one is X plus A. That's the relationship between the two numbers. Do you guys agree that one is A larger than the other one? Okay. Trying to get you to think abstractly. See if we can do this one. Twice a number. First of all, you got to give your number a name. What do you want to call him? X. Let's call him X. So if our number is X, what would twice the number be? 2X. Exactly. So 2X would be twice the number. See what we're doing here? We're building abstractly. One number is A. One number is A more than another number. One number is A more than another number. I'll give you a hint. It's basically the same as the first one, isn't it? Yeah, X and X minus A, or we could call it X and X plus A. It depends on which one the larger number is, and you'd have to set it up your particular way. Number 1 and number 3 are really the same. They're just worded differently, right? So what you're going to find is you're working on an application problem. Let's say Martin's working on an application problem and Riley's working on the same problem. Martin might say, hey, I'm going to let one of my numbers be X, and I'm going to let my other number be X plus A. Riley might say, I'm going to let one of my numbers be X, and my other number is going to be X minus A. They might set it up differently. But if they arrange their formulas and their computation the same, they're going to get the same answer in the end, right? There's more than one way to approach these. That's why it's important that you keep your variables straight in your mind. We often write it down. Let X equal whatever it is and write it down. Let x plus a equal whatever it is, and write it down. And that way you can keep your thoughts organized as you build equations. That's what we're doing here, is we're building expressions, building equations. Okay, one number is a less than twice another number. One number is a less than twice another number. So first establish your first number, give them a name, and now try to come up with your second number. How would you express that? A less than twice another number. Anybody want to take a stab at it?
X minus 2x.
Not quite. You didn't involve a, right? We want whatever a is some number. We want to be a less than twice the other number.
X, so then 2x minus a.
Yeah, very nice. Do you guys catch that? X could be one of our numbers. And then I want to be a less than twice that number. So if x is one of our numbers, a less than twice that number, well, 2x is twice that number, and if I go a less than that, I would subtract a. That would be my other number. Right? Very nice. The product of a number and a decreased by b. The product of a number and a, so product is multiply, right? So we got some number times a decreased by b. What do you think? Product, let's just do the first half of it. Let's skip the decreased by b. What happens if I wanted the product of a number and a? What would that be? ax. Yeah, a times x, or xa. Doesn't matter, we can put them in either order when we multiply, right? So ax would be a times x. Now I want to take that value ax and I want to decrease it by b. Minus b. So ax minus b would represent that situation, right? Okay, here we go. The quotient of a number and the number plus a is 3 times the number. Woo! Give you a minute to digest that one. This one is kind of yucky. The quotient of a number and the number plus 3 times the quotient of a number and the number plus a is 3 times the number. Give you a little hint. What does the word is mean in math? Equals. So when you run into the word is, you can insert an equal sign there. Because if something is something, that means something equals something. So look at the part before the is, just on the left of the is. The quotient of a number and the number plus a. Quotient means division. So I'd have like a fraction, right? I'd have a numerator and a denominator. It's the numerator divided by the denominator. So what's my numerator? Yeah, some number. It says the quotient of a number. So we can just call it x. So x is in the numerator. And then what's in the denominator? X plus a. Yeah, the number plus a. So I got x over x plus a equals 3x. I think that's what we got there. X over x plus a equals 3x. Yikes. Are you guys able to read that from the back? The product of 3 times a number and the number decreased by b is c. I'm going to give you a minute to see what you come up with. Product of 3 times a number and the number decreased by b is c. Flag me down if you got it. Yes. All right, good. close. The product of 3 times the number and the number. You've got the product of 3 and the number. We want to take 3x times something. You're close. Yes. You have the same thing. Help me out with your name. Kenzie had. We want to take 3x times something. It's close. You might want to break this down. And now, if you guys had a piece of paper in front of you with this on it, it might help because you could draw lines on the paper and you could organize things out. 3 times a number. What could I call that? 3 times a number. 3x, right? 3 times the number is 3x. I want to take the product of that. How about the number decreased by b? What is the number decreased by b? X minus b. So I want the product of those two things. So I want 3x times x minus b. And if 3x times x minus b, what is it going to equal? C. So we got 3x times x minus b is equal to c. Okay, let's try a couple different ones here. Give an algebraic expression for each of the following. Tom's annual salary is $4,000 more than Jim. Tom makes more money than Jim. If Tom's salary is T, what is Jim's salary? And don't say J. We could call it J, but now we have 2 variables, right? Notice it says, what is Jim's salary in terms of T? So we want to represent both Tom and Jim, but we only want to use one variable, and that one variable is T. So Tom is T. What is Jim? What do you think? T minus 4,000. Good. Was anybody tempted to say T plus 4,000? Do you see where somebody might have wanted to say T plus 4,000? Because they see the word more, and more you think add, right? But you got to keep your data straight. Who makes more? Tom makes more. So if I take Tom's salary and I take $4,000 away from Tom, would it be equal to Jim? Yes. Very nice. Okay. Dr. Worth weighs 185 pounds. He is gaining 5 pounds every month. If X represents the number of months from today, give an equation in terms of X that would model Dr. Worth's weight W. So we want W equals. W equals. I want an equation this time. What do we think? An equation in terms of X.
185 plus 5x.
Very good. 185 plus 5x. Do you guys see that? 185 would be the starting point, and every month would be X. And what happens every month? 5 more pounds. So I would take 5 times the number of months. Very nice. An item at the store has a regular price of P, but it's marked on sale 30% off. If S represents the new sale price, express S in terms of P. You're trying to solve for the sale price, meaning how much are you actually going to pay for the item. So you're shopping. Hey, look at that awesome jacket. What's the price? It's P. Oh, but it's 30% off. What are you going to do?
7 over 10 times P.
7 over 10 times P? Do you guys agree? Where did this 7 business come from?
Because that's 30% off is how much P take off. So you just got to pay the other
Right.
7%.
Very clever. Yeah, and you said 7 over 10, which is the same as 70%. Did you guys catch that? So there's 2 ways that I think we could write this. One way would be to say, I'm going to take P, the regular price. I'm going to calculate what 30% of the price is, and I'm going to subtract that 30% off because it's 30% off. So I could take P minus 0.30P. But if I gather those like terms, like Riley did, He was clever enough to do 2 steps in one. If 30% is the off, doesn't it mean 70% is still on? So you're going to pay 70% of the regular price. So either one of those would be appropriate. What do you think the most common mistake would be for a student who gets stumped on this? What would they call S? They would call S 0.3 of P. Do you see the problem with that? Are you going to pay 30% of the price? No, that's the amount that's coming off, not the amount that you're going to pay, right? So that would be a common mistake, just to call it 0.30p. Okay, very good. Don't think too hard on this one. You have $100 in your pocket. You spend X dollars at the store. In terms of X, how much do you have left? 100 minus X. Very good. You don't know what X is. You just know that you have 100 minus X left over. So X is the amount that you spent. Very good. Last one. Here we go. See if you can figure this one out on your own. What is the number? 5 times the number is decreased by 4. The result is 26. What is the number? You already got it? Okay, keep it to yourself. Let everybody have a second to think about it. You might be able to do this in your head. But even if you can do this in your head, I would challenge you to maybe write down the equation that is applicable here. Write down the equation that is applicable. So you're taking an English sentence and you're trying to change it into a math equation. That's what we're doing here. Five times a number. 5x is decreased by 4 minus 4. The result is equals 26. What's my number? 6. Yep. If I solve that equation, I get 6. There it is. X equals 6. Okay, so this is just a snapshot. I think this is from a different textbook. But we're going to work on these application problems. Some of them are going to be videos. Some of them are going to be written. Some of them are going to be different scenarios. Here's what you need to be able to do. Identify your known quantities. Like, what do I actually know? And write it down. Identify or assign a variable to represent your unknown quantity. Let X equal something, whatever I'm trying to solve for. Let T equal. Let N equal. Let. And write it down so that you can keep it straight, right? If there's more than one unknown quantity, find a way to write the second one in terms of the first. Remember Tom and Jim? If Tom is T, and I know the relationship between Tom and Jim, there's no reason to introduce a second variable if I don't have to. I don't want to have both a T and a J. If I could just limit the number of variables that I use, that's going to make life easier. That's why I would write T and T minus 4,000. Write an equation interpreting the words as a mathematical operation. That's what we just did. And then finally, we got to be able to solve that equation. Okay? So I want to give you, let's see, we are just about out of time. I'm going to give you I'm going to give you a couple to work on here. Let's see, where am I at here? Before we go today, I'm going to have you work on these and then just try to bring them back to class. I don't have it ready for you. I thought I was going to get there, so I'm going to email it to you. Hang on one second. Okay, I'm going to give you a couple of, 3 of them, I think, to practice, and see if you can just come back, just on a piece of scratch paper, come back with the answer on Friday, okay? And then I also want you to start working on your 2.2 quiz, the My Open Math quiz on there. And look for an email from me in about 5 minutes here with the ones that I want you to practice, okay? I will see you on Friday.